Hello everyone and welcome back to another video. So today we're going to be solving the LeetCode question collecting numbers. Alright, so in this question you're given an array that contains each number between 1 to n exactly once. Your task is to collect the numbers from 1 to n in increasing order. On each round you can go through the array from left to right and collect as many numbers as possible. So what will be the total number of rounds in order to collect all of the numbers from 1 to n? So let's see what this actually looks like, and let's say we have this input as an example. Okay, so let's say we have 4, 2, 1, 5, and 3. Now in the first iteration, what would happen is we want the number 1. So we go 4, then 2, and then we first get the number 1 over here. So this is the first iteration. Now after 1, we want the number 2. So then we have 5, and then we have 3. So we did not get the number 2. So in the first iteration, we just got the number 1. Okay, so this is the first one. Now let's see what happens in the second iteration. Now in the second iteration, we first go to 4, then we go to 2. The number we're currently looking for is 2. So we go over here, and then we want the number 3. So then we have 1, and then 5, and then 3. So we get 3 as well in the same iteration. So in the second iteration, we get 2 and then 3 as well. Cool. So now we move on to the third iteration. So now we get the number 4. So we have 1, 2, 3. Now we get 4 over here. And then now we need 5. So 2, 1, and 5. So that's it. So to get all the numbers, it took us a total of 3 iterations. And the output of this is going to be the number 3. Okay, so the question here is pretty straightforward. And let's just see what a perfect case would look like. So in a perfect situation, we would have something in ascending order. 1, 2, 3, 4, 5, for example. So in this case, what would happen is we just need one iteration. So first we would get 1, and then 2, and then 3, and then 4, and then 5. Okay, so we just need one iteration to get all of the numbers. So now let's see how we can actually come up with a simple solution. Now, the most brute force or naive solution is going to be to simulate this, right? So we could have a while loop on the outside, and inside of this, we could iterate through all of the n elements, okay? And each time we can just simulate it. So first get 1, and then 2, then 3, and so on and so forth. So in this case, we would do this for loop would run for 3 times. But in a worst case scenario, when we have something which is in descending order, so let's say we have 5, 4, 3, 2, 1. So this is the worst case. Over here, it would actually take us 5 iterations. So in this case over here, we would have to go through the for loop a total of 5 times. So this is a lot. And especially when we have a condition like this, where it could be all the way up to 2 to the power of 10 to the power of 5, right? 2 times 10 to the power of 5. So let's actually come up with a simpler solution where all we care about is the position, because really that is all that matters. Now in this case, the first number we get is the number 1. Now the next number that we can get is something to the right of it, and that's going to be the number 2, the next number. So the basic observation that we're making over here is that given a position of x, if the number x plus 1 exists to the right of it, then in that case we could get it in the same iteration. Now in this case, let's take the number 2 for example. Now the next number was 3, right? And 3 was to the right of 2. So that means we could get it in the same iteration. So what we're going to do is we're going to look at the position of each of these values, and based on the position of them, we're going to find out how many iterations it takes us. So let's see what that looks like. Okay, so what we're going to do is we're going to make another array. Let's just call this the index array. And the purpose of this array is to keep track of what index we're currently on. Okay, so we're going to have a total of 5 values. So this is going to be the 0th index, first index, second, third, fourth. Now we need 5th. Yeah, just one more. Okay, so 5th index. So now what we're going to do is we're going to iterate through this. Now the first number is 4. So now we're going to go to the 4th index, and we're going to keep the value of where the number 4 exists in this array. Okay, so essentially over here, the number 4 exists at the 0th index. So in our index array, the 4th index is going to have a value of 0. So this tells us the number 4 is at the 0th index, okay? So let's just keep doing that. So now the number 2. So number 2, and now by the way, this is going to have a length. So if this has a length of n, this is going to have a length of n plus 1. And the reason for that is because we want to account for the last number as well, okay? So, so now let's go to the number 2. So we go to the second index here, and the index where 2 is at is the first index. Okay, so it has a value of 1. So the number 2 is at the first index. So now the next number is 1, and 1 is at the second index. Cool. Now 5 is at the third index, and finally we have 3, which is at the fourth index. Okay. So now obviously we're not going to have the number 0, so we're just going to leave it at, we're just going to give it a default value of 0. So now what we're going to do is pretty simple. So we're going to iterate through this array, and at each time, so we're going to start off with the number 1. We're going to check if the position of this value is greater than the position of the previous value. Now, if this value, the current value x, is greater than the position of whatever is at x minus 1, the previous index, that means that we could get them in the same iteration, okay? And the logic behind that is very simple. And so the best way to show that is just to show you a array which is in ascending order. So let's say we have 1, 2, 3, 4, 5. Let's make the index array of that. Okay, so the index array here, so 1 is at the 0th index, 2 is at the first index, second, third, and fourth, and 0 is going to be, well, 0. So what we do over here is we check if, so starting off at the first index, if this current value is greater than or equal to the previous value. And if it is, then it's going to be part of the same iteration, okay? So it is in this case. Now we go to the number, so the second index, and over here, this is at the index 1, while the previous number was at the index 0. So what this is saying is the number 2 is to the right of the number 1, okay? So it's in the same iteration as well. Now the same way we go to the third number, and this is 2 is greater than 1. And in the same way, 3 is greater than 2, and 4 is greater than 3. And what this is telling us is that everything could happen in the same iteration, and we don't actually need any extra iterations when it is in ascending order. So our answer is just going to be 1. So let's do the same thing, but for this example over here. So we're going to start off with our result having a value of 1, because the minimum iterations is 1. We check if 2 is greater than or equal to 0. It is. So this is part of the same iteration. Now we check if 1 is greater than or equal to 2. It's not. Okay, so in this case, it is not part of the same iteration. So now we had to increase the iteration by 1. So now we have 2 iterations. So now we go to the number 3. So in this case, 4 is greater than or equal to 1. So in this case, this is part of the same iteration. And if you remember earlier, this was the first iteration. And in the second iteration, we had 2 and 3. And that is exactly what is happening over here. Now we go on to the number 4, and over here the value is 0, and 0 is not greater than or equal to 4. So this is going to be a new iteration as well. So we increase our result to 3, and again, I hope you, so if you remember, the 4 and 5 were its own iteration, and that's exactly what's going to happen here. So now at the fifth index, 5 is at third index, and 3 is greater than or equal to 0. So this is not also part of the same iteration. So now the final answer we're left with is the value 3, and that's what we end up outputting. So hopefully you understood the logic. It's pretty straightforward, and now let's just see what the same thing looks like in code. Okay, so over here we have our value n, which is going to be the length of the array. Then we have x. So x is just going to be a temporary variable where we take the input, and the count is going to be what we actually end up outputting. And it's going to have a value of 1 in the beginning. So over here, we take the value n, and then we make our index array with a length of n plus 1. Okay, so what we're doing actually, we're actually directly adding everything to the index array. So we're taking the input and storing it in a variable x. And then in the index array, we're going to the index x and giving it a value of I. So in the beginning, that tells us the first number is at the index 0. The second number is going to be at the index 1, and so on and so forth. Okay, so we're directly making the index array instead of first making the array and then the index array. And we need to make sure that whatever is at the 0th index is equal to 0, because we're not giving it any value beforehand. Okay, perfect. So now by the end of this, we have the index array form. Now what we're going to do is we're going to iterate through the index array. So we start off with the first index, and one thing I made a mistake with, and that's why my submission kept getting wrong, is I only went up to n. But in this case, the length of the index array is n plus 1, not n. So we got to go until n plus 1, and each time increase I by 1. Perfect. So over here, the condition is if if the value at the index I is less than whatever the previous value is, then in that case, we're starting a new iteration. So in that case, we're going to increase the count by 1. Okay, and we do this for everything, and at the ending, we just output our count. So that should be it. And if you submit this solution here, it will get accepted. So yeah, thanks a lot for watching, guys. And do let me know if you have any questions.